2.6, we want to talk about prime number factorization. So first of all, we want to define what is a prime number. So a prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. So a prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. So a prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. So a prime number is a whole number. So it must be a whole number which is greater than 1 and only has two factors. So what is a composite number? A composite number is a whole number that has more than two factors. So a composite number is a whole number that has more than two factors. So a composite number is a whole number that has more than two factors. So a composite number is a whole number that has more than two factors. So then in example 1, we want to tell whether each number is prime or composite. So for 19, we try to divide 19 by 1, right? It's 19. How about 19 divided by 2? Okay, there's nothing. So 19 is a prime number because 19 can only be factored as 1 times 19. So therefore, 19 is prime. Okay, then for 20, let's try to factor it. So we do short division starting by 20, use the smallest prime number, 2, I get 10, 2, I get 5, and then that's the end. So the factors of 20 is 1, oopsie, the other page. So the factor for 20 is 1 and 2, and then 2 times 2, which is 4, and then 5, and then 4 times 5, which is 20. So 20 is composite. So I want to talk about prime number factorization. So prime number factorization is when the a composite number can be written as the product of its prime factors. Okay, so we can use a factor tree or we can use a short division. So prime number factorization is a composite number, is when the composite number be written as the product of its prime factors. So prime number factorization comes when the composite number be written as the product of its prime factors. Okay, so we want to learn how to write as a factor tree. So starting by 36, and then we have, when we do prime number factorization, we have a tradition that we always start by the smallest prime numbers. So we keep dividing using from the smallest prime numbers. So we start from 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So, and etc. So we start by 2, and then we figure that this is 18, and then this part is done. It's just 2. This part, again, we use 2, and then 9, and this is done because it's a prime number. When we hit a prime number, we stop, and then prime number, that we stop. So the prime number factorization for 36 is 1, 2, 2 to the power of 2 times 3 to the power of 2. And then now I have 280. So I want to do the prime number factorization for 280. Okay, so again, I'm going to use a factor tree to 140 to 70. When I hit prime number, I stop 235. Then 2 cannot, 3 cannot, 5 and 7. So I stop. So I end up having 1, 2, 3. So 2 cubed times 5 times 7. Okay, so after the factor tree, we want to try to use a step diagram to find the prime number. Factorization. So again, I started by the smallest prime number, started by 2, 2, then I use 3, 3, so end up having 2 squared times 3 squared times 7. So then for 495, start by 2, not going to work, start by 3, start by 3, not going to work, start by 5, then again, okay, I'm sorry, I made a mistake. So to do this short division using steps, I need to start by the smallest prime number, and I have to keep doing it until it's no more. So this can still be 3, and then 5, 11. So I need to start from the smallest prime number, and then factor. Okay, so start by 2, 3, 5, 7, 11, 13, 17, 19, 23. And then keep factoring it until there's no more. So, like this. Okay, then let's do think and discuss.